Govinda Charyulu sir. Before sir starts, I would like to introduce him, Professor B.A. Govinda Charyulu sir. Now, he is Director Manjira Digital Systems, Gachibowli. He pursued his BSc 1968, MSc 1970, Andhra University, PhD from IISc Bangalore in 1976. He has vast experience of 36 years over in 22 years in semiconductor IC industry, VLSA and MMIC. He was professor in Vasavi College of Engineering from 2004 to 2019 after coming out from GATEC. SCL Semiconductor Complex Limited, Chandigarh, 82 to 95. I think he is the right person to tell us so what is SCL is doing, so what is the semiconductor IC design, what are the technologies and all. And he was in IIT Kharagpur 1981 to 82, and he was in IISc Bangalore as a research associate 1976 to 80, and he published over 30 technical papers. We welcome you, sir.
To invited me to present a topic of interest to me here. Okay, my association with Osmania University is almost 2004 onwards. That means almost 2 decades. I have been, besides teaching at Vasavi, even earlier to that, 95, to be exact 95, when we had Professor Pandari Pandey asking him to give some lectures from that time it has started when I came to GATEC. So I was also teaching here at Osmania while I was there. The Osmania University requested me to teach VLSI related subjects. So we have been organizing many events. This is one of the events under CAS EDS Society. So let me, mostly I worked with Semiconductor Complex Limited, Chandigarh for about 23 years, out of which about 13 years I spent in Chandigarh and then another 10 years in Hyderabad at GATEC, okay, which was a project with SCL at that time. So after that I joined Vasavi College. Okay, so I will be mostly talking on the semiconductor technology scenario in India. We will start with, this is the agenda what I have put. We will look at the semiconductor technology evolution, how it has come, international scenario, then what are the efforts of in India, okay, what are the things that have been done, and then what is the way forward. So this is my plan of presentation. Okay, I think most of you people should know how the whole electronics field itself has started. Okay, first with the vacuum diode, then triode. I don't know how many of you have worked with vacuum devices. Way back when we were in, I was doing my MSc as well as PhD, we have been using vacuum tubes a lot. But afterwards, first transistor I saw in 1970. My professor will not give me the device because he says it's too sensitive, he will soil it. That kind of thing. From there, it has leaps and bounds, it has gone. That's what we said. Then the first was the point contact bipolar transistor by the trio, you know, well known. First silicon based planar transistor was made by Gordon, and with the invent of transistor, the microelectronics is done. Okay, so from that simple thing, now you see the huge development, leap and bounds. You can talk of any VLSI IC, it has got millions to billion transistors on a single chip. I always tell this story. The first mobile what I bought was a small one with a small antenna. What all I could do is I was able to talk to somebody, receive a call and play some silly games on that. But now, at the time the cost was about 10,000 rupees. Now for same 10,000 rupees, you know, everybody knows, everybody has a mobile of that kind, the capabilities what they can do. Okay, integrated circuits. The first silicon chip was the Jack-Kilby, everybody knows that. And then the MOSFET was invented, RCA. Okay, RCA was the first company to have developed MOS chip and later CMOS chips. Okay, then from there you have seen advantage of low power and things like that. So this is the, I don't think I need to go through this. Everybody knows development of the ICs, SSI, MSI, LSI, VLSI, ULSI, GSI. Semiconductor integrated circuits since 1960 it went on developing to huge kind of thing. Now right now we have Earlier, when we started the technology, we talk of microns. The first was about 15 microns. What 15 micron means the gate length. Okay. From there, it went on 15, 10, 5, 3, etc. Now you have 5 nanometers and the special devices like FinFETs and things like that. The huge revenues are billions of dollars. I don't want to talk much about this. Okay. It was revenue of about $400 billion in 2021 and then expected to grow a lot value like something like 40, 50 billion dollars per year. This is the semiconductor ecosystems. What you have is that there are foundries fabricate chips, then they do most of these days. Very few companies have in-house fabs like Intel and things like that, but most of them are foundries. TSMC, Global Semiconductors and all those things work as foundry. You make a design, give it to them, they will fabricate for you. It started in way back 1950s. There were discrete devices that were being made. Continental devices, semiconductor. These are making small devices like some of them medium power devices and things like that. Major thing has come with Bharat. Initially, they started with germanium kind of devices, AC series, AC, AF and then this kind of devices. On a small piece of germanium, they add the source and emitter and collector contacts, then make transistors. But really the silicon they started used to be the main supplier of all the transistors. BC series, I am sure everybody would have BC 147, 107, all those kinds of things. Okay. And then the integrated circuits also started in BEL. They got bipolar devices, okay, and then also CMOS devices, 7 micron, which licensed from RCA. As I said, that was the first organization, first company to introduce CMOS devices, okay. And then I remember one of these, when I was there in Bangalore, I have seen at that time they designed a wristwatch based on their technology, and I have seen that. So that is quite a bit of achievement from there. Unfortunately, for whatever reasons, that has not been pursued further. They had a very small fab, but they did not pursue to higher geometries and things like that, better geometries. Now, SCL, Semiconductor Complex Limited in Chandigarh, okay, this is the first real VLSI company in India, okay, and then under the government's approval and funding, the basic concept started in 72, and then its location was decided in 1977. Work started in sometime in 81 and then 1983 with a 5 micron CMOS technology licensed from American Microsystems USA. Okay. We at that time we had the 4-inch fab facility, okay. Then assembly test, it is a what we call the vertically integrated facility. You have wafer fab, you have the assembly, testing, packaging, everything was included in that. Okay. Dr. Zarabi, who was the R&D chief there, insisted, he was also project manager initially, insisted that a R&D facility should be set up at SCL along with the production facility, so that the next generation technologies will be done. You know very well, the generation technology changes every 2 years. So, just generation to 5 micron was 3 micron, after that 2 micron, 1.2 micron, etc., etc. Okay. So, a R&D center was set up. Dr. Zarabi was the R&D chief at that time. I was looking after the technology development. We successfully developed 3 micron technology first, then followed by 2 micron technology. At the same time, we didn't stop there. we went to other technologies like high voltage CMOS, then we had CCD technologies, etc. That was also you have the non-volatile memory technology. A team was sent to USA to collaborate with our AMI to develop this jointly this technology. Okay. So, you can see that the analog clocks what you see everywhere in this one, this was conceived and developed at SCL. At one time practically each and every device was, every clock was having SCL chip. Initially we had, the design was in 5 microns, then the design was transferred to 3 micron. When we did that, the about 1200 devices per wafer, 4-inch wafer, jumped to more than 3000 devices per wafer. That is huge. So, resulting in the much cheaper devices that can be done. That is a basic advantage. So, then afterwards we went to 3 micron, we went to 2 micron, 1.2 micron, etc. And other things depending on the requirement of the country, CCD technologies were developed basically for imaging applications. First was the 100 by 100 CCD array, which was supposed to be a readout for IR camera. Okay, that is what I said, 3 micron, 2 micron images, as well as special technology like E squared prom, and then CCDs for imaging applications. Okay. Then of course, this goes by government has been funding the R&D center a lot. Okay. So, we have developed by 2005 designed and developed over 80 products. These are ASICs that are supplied to DRDO, space and things like that. Okay. So, there are quite a few number of devices, charge coupled device multiplexer array as ROIC, all this I was mentioning that, and then for IR filter sonar applications and particle detection, dosimetry, analog signal processes. Unfortunately, what has happened was in 1989, I do not know if anybody aware of that, we lost the facility in a major fire. Okay. So, whatever development work at that time suddenly came to a standstill. Then there are a lot of customers who have been supplying. So, what will they do? Then consciously with the approval of the government, we entered a collaboration with Austrian Microsystem, where because they had the same origin of AMI, so technology was similar. So, we went there, fabricated all the devices that are, so the customer is not affected by this one. And then parallelly we asked for a starting a new facility with that. So, accordingly it was approved, and then we built this, and then this has become operational in 1998. This in collaboration with a Tower Semiconductors, we run 180 nanometers devices here, and this is still running. Most of the customers are space, and as a matter of fact, after some time there was a conscious decision on the government that the facility, Dr. Zarabi retired in sometime in let me see 2005 or so, then a conscious decision was taken by the government to hand over the SCL to space. So, under space this was running for quite some time, all the space requirement like CCD images and things like that were fabricated, designed and fabricated here. Okay. Quite a few devices are flowing in satellites that are moving around. So, as I said, 1998 started, allowing to be sole agency supply electronic other circuits, also was working for the industry, that is what you are saying. I was mentioned about watch circuits, and then lot of the other customers like defense and space. After some time, it was the lack of funds that are coming, so it was development done. Okay. And then are handed over to ISRO, and many ASICs and SOCs have been developed in collaboration with IIT ISRO, DRDO, etc. SEL also supports by providing the design kits. Any prospective designers, you can take the PDKs and then design the circuits. You can put them in what we call the multi-chip wafers. So, number of designs can be fabricated on the same wafer, so that you save a lot of money in verifying your own design. This is the one of the facility, picture of the facility, which was done in some time after with the tower semiconductors. Now, under SEL, there is another facility that is right sitting in Hyderabad called Gallium Arsenide Technology Enabling Center, simply called GATEC. Okay. This facility is set up for meeting the requirement of RF devices, MMICs required for many strategic applications. At that time, these technologies were not available to India. Okay. You cannot buy a gallium arsenide devices from abroad, especially if you are looking for a defense or strategic applications. So, consciously they have taken a decision, and then DRDO decided to establish this facility. Okay. And then this was done. It's a vertically integrated facility, as I said, design, wafer, fab, assembly, testing, including the QA facilities. Okay. Initially, it was assigned to SEL to establish and run it for a few years, and then 0.7 micron MESFET technology, 12 gigahertz was implemented, and this facility was based on technology developed by SSPL. It's developed in a short time. The facility was brought up and then developed in a very short time, okay, to bring the first devices. Then afterwards, we supplied the devices, ISRO, defense, etc. Okay. And then quite a few of devices also have flown in the satellites. And then one of the important things was what we call the TR module, which is used for synthetic aperture radar applications. Okay. So, when I went to SAC some time back, they showed me the maps of the earth. Hey, this is your product that has come out of your product. This was done, taken over by DR up to 2004, that is 93 or 91 or so, to 2004, it was being run by SEL, and then that is decided to take over and run it. Now, it is being run by DRDO. The facility is under society called SITAR, and under SITAR there is another facility in Bangalore in the ITI campus. They were also started with the CMOS. I think if I am correct, mostly they are concentrating on MEMS technologies. Some of the projects that are done started with, as I said, 0.7 micron MESFETs, then amplifier, switch circuit, all those kind of things. That what basically this is the TR module components, and then PHEMT MMICs, wide band, low noise, high power amplifiers, controller, all those kind. And Schottky barrier diodes, which can go up to 3 terahertz, and then laser diodes. Now, they also started consciously, everybody is going on gallium arsenide based technologies. So, gallium arsenide technologies also have been established, 0.4 micron gallium arsenide HEMTs, and then the next generation is under development. The government of India has constituted to empower committees, look into this aspect, how to go further, because 130 nanometer, 180 nanometer is not the only one what you have. Many devices can be taken, everybody is going out to higher, better geometries. So, the government has constituted empower committee, they gave a recommendation. As a result of that, okay, they try to form consortia. Initial was not very successful, but later then it has come the India Semiconductor mission, and then you see that as an effort of that quite a few organizations are coming. I will give a list in a minute. Okay. One of the important aspect is they have budgeted 76 crores, about 10 billion. So, this is the one. One of the important thing in this is the establishing a facility to making wafer fab is not just sufficient. Needs very much sophisticated equipment for the processing, wafer processing. Clean rooms need to be established. So, all those things involves. So, the specialized chemicals and gases that are used also have to be brought. Unfortunately, we do not have any such facility which can supply the specialty chemicals and specialty gases. So, I hope somebody, of course, and most of the things in either this one or other things, you need to aim at the global market rather than just Indian market. Indian market may not be able to sustain. That is one direction. It is very expensive. We know that. While we started with development of 3 micron, when we developed the 3 micron, SCL was just one generation behind the world level technology. Everybody was using, going to 3 micron they were producing, 2 micron was being developed. We developed the 3 microns. By the time 2 micron, then we also had plans. Unfortunately, after that we had the fire accident, and subsequently not much of a support had come. So, it has not beyond a certain level of development. And you know that very well, India engineers are very strong in design. You have companies like TI, Motorola, Intel, AMD, where all our engineers are working. Okay? They work for their own designs, okay? But we do not have much of a activity going for what we call IP development within the country. Okay. So, that is one aspect that has to be considered. It is very, very important to have our own IP, so your general value will go up. This is what I said. Number of local semiconductor design companies were set up by the for outsourcing this one, and then some companies have started and organizations have started developing their own IPs. One of the good example is my own company, Manjira Digital Systems, where a very specialized processor, which is a programmable, low power, high efficiency processor used for AI, DSP and many such applications. We are using it for, we are developing a GPS NAVIC module based on our chip, is silicon verified IP. Okay. Now, other organizations like IIT Madras, IIT Bombay are also engaged, and then like Shakti and then Vega of CDAC and all those things. The design. So, this hopefully this trend continues, and you will have a lot of IPs developed within the country, so that your market value will go up, because that is the 50% of the semiconductor value design is in the design, and you have to own the designs. So, again as I said, limited addressable market of chips in the country, further compounded by diversity of the chips. Okay. So, how to address this problem, whether you can address using these foundries the global markets, and that is the one what has to be looked at. Okay. And then the long time policy has to be done. Okay. The micron technology. So, this is what is happening in the present. Some of these recent developments you see, micron technology plant in Gujarat, Tata Electronics and supply with PSMC at Dholera, Gujarat. This is also coming up. Tata Electronics outsource assembly and test, okay, in Assam. Another at Sanat, Gujarat, Rajasthan, Cairns, and then other things. I think there are companies like L&T and others also showing interest in this area. Hopefully, this will build up, especially with the scenario of it's a good opportunity for India, because most of the designs are depending on China because of the whatever reason. So, if we can catch this opportunity, of course, lot of difficulties, challenges are there. This has to be overcome with a kind of policy decisions and things like that. Okay. Now, it is required, it cannot be done by private companies, it has to be strong support has to be given by the government and state governments, like TSMC is mostly supported by the government, and then you also have South African facilities. They are all governments, lot of government support is there. Even you can see in the US, they are trying to support the establishment of wafer fabs within USA, trying to move away from the other places. When you are established the facility, buy some technology from outside, that should not stop there. R&D has to be done. The next generation technologies you have to develop. Don't depend on somebody else to give you the technologies. And that will save a lot of money, of course, it is a prestigious point of view, but you will have a lot of savings in the money. Buying a technology, ready-made technology is going to be very, very, very expensive. Support market consolidation, addressable market, okay. A good example is the clock and watch policy in 1983, which has helped SCL a lot to bring out these products. Okay. Almost all the wall clocks and then the movements. And then this is what I said, need for building, owning portfolio of IPs required for product analysis. This is again, I don't have to emphasize much further. This is a need of the day. So, make a strong base in the country. Now, SCL somehow has been neglected, I would say. Now, needs a strong support to revive it back its original glory and then become a center for these kind of issues. Okay. And then this one important aspect is they can have what is called multi-product wafer runs, which is useful for any of the designers. Support to GATEC, again same thing, funds important because market is small. Same situation had come with SCL. That has to be supported, facilities have to be supported. Okay. So, this is what I have. I would like to acknowledge here my earlier boss, Dr. Zarabi, who was the CMD of SCL and active member of empowered committees. So, some of the thoughts he shared with me, which I have presented here, and also I would like to acknowledge the CEO of GATEC. Earlier, I was in that capacity. I was the director of GATEC before I moved to academics. Okay. So, this I would like to. That's all what I have. Thank you very much. Any questions, I hope I will be able to answer.
My question is, IC fabrication is done using the so far silicon material, right?
Yeah.
So do you mean saying this gallium arsenide means fabrication is done using that material?
Gallium arsenide based devices, what happens is the modern devices, they are very complex devices. Of course, still that kind of approach will continue. Okay. Mostly it will affect the back end processing.
Yes,
that is the layout and things
for
like
those
that.
people it is.
Yeah,
like
that will be there in the layout.
that.
Yes.
But the front end designer still
Front
can
end
continue
design
with
will
that.
be continue like as it is.
Yeah, thank you for
Kumar from Vasavi College of Engineering.
Okay.
So I wanted to know because you have worked with 3 micron and 1.5 micron after that.
1.2, 2 yeah.
Gallium arsenide and gallium nitride high electron mobility transistors.
Right.
So what challenges you have observed when you are transforming one technology to the other?
Okay. I didn't want to go into those details. See, there will be always be challenges. For example, you transition from 5 micron to 3 micron. 5 micron, of course, gate length is 5 microns. There is below that mass device oxide thickness, and then the source drain structures and things like that. Now, it becomes slightly different when you go to 3 micron. The oxide thickness is smaller. Okay. Then the source drains have to be specially designed. So, this has to be worked out. What we do is, these are called unit processes. Before the development of the real technology, what we do is, we go through this process. I had to grow a 300 angstroms gate oxide. What do I do? How to go about it? Quality of the oxide, all those things are done. Similarly, source drains, there has to be, the depth has to be smaller. So, there has implementation, evaluation technology. Then after all these things are done, then you go for the integration of the process, putting all these units together. That's how lot of challenges, even for gallium arsenide. Okay, we had that is a completely different kind of technologies. Most of the time, you have the lithography, which is the most critical. This has to be properly developed. So, a lot of challenges were there. We faced all of them, and then overcome. So, you can see the effort of this thing, right? Any other question? Yes.
TSMC and
Yeah.
UMC, they provide PDKs, right?
Yeah.
So we make use of those standards as a digital designer.
Yes.
They develop their designs.
Yes.
So who are the companies who are providing the PDKs based on this gallium arsenide?
Gallium arsenide PDKs are available, but they are not giving out to the general circulation because it is a defense facility.
Okay.
They are not so open as the SCL, which is an open foundry.
Like TSMC, UMC, we have.
No, SCL also provides those PDKs.
Please
You can get the
maintain
PDKs from SCL Chandigarh.
Okay.
You can make the designs and then get them, so give the design to them, and then you can get the devices fabricated, get it tested, and verify your design.
Okay.
That is
Thank you, sir.
available at SCL. At GATEC, still they have not taken that kind of decision
Thank you.
because it's being a very specialized defense facility.
Thank you.
Thank you very much, sir, for your valuable insights.
Thank you.